Hello, welcome to Advanced Composites. Today is the fifth day of the ongoing week, which is the sixth week of this course. And what we will do today is we will start our discussion in the context of case C and case D of the semi-infinite plate problem. Now, in both these cases, unlike cases A and B, the lamination sequence is not symmetric, and we will see that how this influences the overall solution. One thing, based on the discussion which we had just yesterday, one thing we will very clearly see is that the in plane part of the problem and the out of plane part of the problem, their solutions will be coupled. So, that is one thing we will see, and then we will also see some other things which emerge out when we actually solve this problem. So, let us recap. Case C is one end is pinned and fixed, and the other end is pinned but on rollers. So, here U, V, W and Mx, they are all 0, and on the other end you have Nx, Nxy, W plus and Mx plus, they are all 0. Okay. And on case D, both the ends are pinned as well as fixed. So, U, V, W, Mx, they are 0 at both the ends, and the lamination sequence is 0 to 92 symmetric in both the cases. Symmetric. I am sorry, this is not symmetric, it is 0 to 92. So, 0, 2 and 92. So, number of layers is still the same, 4 layers, 2 0 layers and 2 90 layers, like the earlier two cases A and B, but the lamination sequence is not symmetric. So, first we will very quickly solve the differential equation. The solutions for differential equation, as we discussed earlier, they are going to be the same, because when we are doing these solutions, we do not consider the effect of lamination sequence, and neither did we consider the effect of boundary conditions. So, if that is the case, then these three equations still hold. So, we will directly write these equations later. So, our three equations which we get from the differential equations is Nx is equal to C1, Nxy is equal to C2, and Mx is equal to minus Qx square by 2 plus C3x plus C4. Okay. So, these equations are still valid. Next, we have to be now more careful when we are doing this problem. So, let us look at ABD relations, ABD matrices. Now, in this system, all the layers are either 0 degrees or 90 degrees. So, it is a cross ply laminate. Okay, it is a cross ply laminate. So, when if it is a cross ply laminate, because it is a cross ply laminate, we can say that it is A16 is equal to A26 is equal to B16 is equal to B26 is equal to D16 is equal to D26 is equal to 0. Okay. And also, because it is 2 layers of 0 and 2 layers of 90, we can also show that B12 is equal to B66, this is also equal to 0. Okay. So, if that is the case, then what do we, so now we start developing relations for nx, ny, nxy. So, what is it? Nx is equal to a11 epsilon x dot plus a12 epsilon y dot plus a16 gamma xy at the midplane. A16 is 0. Oh, I am sorry, but there will also be b terms plus b11 kx plus b12 ky plus b16 kxy. So, now things start becoming messy. So, now let us see which terms can be dropped off. A16 is 0, B16 is also 0, okay. Epsilon y is 0 because del over del y is 0, so this is 0. Ky is 0 because again it is related to partial second derivative of w in the y direction, and kxy is also 0 because kxy is del 2 w over del x del y. So, what this gives us is equal to a11 du naught over dx minus b11 d2 w naught over dx square nx. Okay. So, now you see the coupling very explicitly. Nx is a function of u and w. In the symmetric laminate, this b term would have been 0. So, nx would only depend on u, but here nx depends on u as well as on w. So, it is a coupled problem. Okay. And we know that nx is equal to C1 from this red box, nx is equal to C1. So, we integrate this equation once and we get u naught is equal to C1x plus B11 dw naught over dx plus C5 into 1 over A11. Okay. So, we will call this equation 1. Now, let us look at the relation for nxy. So, nxy is equal to a16 epsilon x naught plus a26 epsilon y naught plus a66 gamma xy naught plus b16 kx plus b26 ky plus b66 kxy. Okay. And let us see which terms get dropped out in this equation. So, a16 is 0, a26 is 0 because it is a cross ply laminate, b16 is 0, b26 is 0, and b66 is also 0. We have mentioned this, and actually also kxy is 0, epsilon y is 0. So, all these things are 0. So, essentially this boils down to a66 k gamma xy, everything else goes away. And gamma xy, if you remember somewhere back we had said gamma xy is del u over del y plus del v over del x, but del u over del y is 0. So, it is del v over del x only. So, we can say that nxy is equal to A66 dV naught over dx. So, this gives us V2, I am sorry, V naught, which is a function of x, is equal to, and what is nxy? Nxy is C2. We have already said that earlier, right, from this equation. Nxy is C2. So, this is equal to C2x plus C6 into 1 over A66. So, this is the expression for V. This is the expression for V. Next, look at mx. So, mx equals B11 epsilon x naught plus B12 epsilon y naught plus B16 gamma x y naught plus D11 kx plus D12 ky plus D16 kxy. Okay. Again, we see which terms can be dropped out. B16 is 0, D16 is 0 and ky is 0. So, what I am left with is B11 epsilon x naught plus, oh actually epsilon y is also 0. So, B11 epsilon x plus D12 kx, that is all I am left with. And this is equal to, I am sorry, this is should be D11. So, this is equal to B11 du naught over dx minus D11 d2w over dx square. Okay. Now, this is equal to mx, but we also have another expression for mx, which is this one, mx is equal to minus qx square plus c3x plus c4, which is valid for all the 4 cases. So, I bring it there. So, minus qx square over 2 plus c3x plus c4. So, if I integrate this whole thing once and I rearrange my things, what I get is B11 u naught minus D11 dw naught over dx is equal to minus qx3 over 6 plus c3x square over 2 plus c4x plus c7. So, this is my third equation. This is the third equation. So, let us quickly see. So, now we have expressions for u, v and w. So, what we see is that equation 1, 2 and 3, u involves dw over dx. So, it is a coupled problem. V does not involve any other thing, and the third equation is B11 times u naught minus D11 times dw over dx. So, again there is a coupling between u and w in the third equation. Okay. So, what we can do is we can solve. So, what we can do is we can use 1 and 3 to solve for u naught as a function of x and dw naught over dx as a function of x. These are simultaneous equations. So, I can solve for u naught and dw over dx. Okay. So, I will get one expression for u naught and another expression for dw over dx, and then integrate the relation for dw over dx to get equation for w naught as a function of x. Okay. So, if I do all the math, so you can do all that math, that is fairly standard 12th standard mathematics of linear simultaneous equations. So, if you do, what we end up with is a relation which looks something like this. I will write it. So, w naught x is equal to 1 over d11. Now, this is not regular d, this is a different symbol d. So, it is not regular. So, I will define what this big d11 is. Okay. It is not like our regular d times q x 4 over 24 minus c3 x cube over 6 plus b11 over a1 1 times c1 minus c4 x square over 2 plus b11 over a1 c5 minus c7 times x plus c8. Okay. And the relation for u naught x is equal to 1 over a11. Again, this is a different a, it is not like our regular a, and this times b11 over a11 q x cube over 6 minus b11 over a11 c3 x square over 2 plus c1 minus b11 over a11 c4 x plus b11 over a11 c7, actually LL is better. So, it will be c5 minus b11 over a11 c7. Okay. And then of course, our v, what is v naught? It is equal to c2 x plus c6 into 1 over a6 6, and I have defined these script d11 and script a11. So, what are these? This d11 equals regular d11 minus b11 square over a11, and this script 11 equals a11 minus b11 over d11 square. Okay. And so, these are uv and w's, and then what is mx is still minus q x square over 2 plus c3x plus c4, my is still minus d12 d2w naught over dx square, mxy is still 0 because b12 is 0. So, this is the solution for both case. So, this is the solution for case C and case D, okay, because we have not implemented the boundary conditions till so far. So, this is the solution which is common to cases C and D. Once again, this solution has a lot of unknowns C1, C2, C3, C4, C5, C6, C7 and C8, and those 8 unknowns will be computed once we start implementing the 8 different boundary conditions. 2 more points. This term, this D11 script D11, this is called reduced bending stiffness, okay, it is called reduced bending stiffness. Why is it reduced bending stiffness? Because D11 by itself is positive and B11 is, so the effective bending stiffness in the expression for W, we have 1 over this script D11. If B11 was not there, then this script D11 would be same as D11, but because this B11 is there, its effective value becomes reduced. So, the denominator instead of D11 becomes script D11, and that is a smaller number. When it is a smaller number, the value of W will increase. So, what this shows, this relation, even though we have yet not implemented the boundary conditions, what it shows is that the presence of B matrix tends to increase the deflection of the plate. In the symmetric laminate, this B was 0, so the deflection would be less because it will be just D11. In unsymmetric laminate, because B11 is non-zero, it reduces the stiffness. Once it reduces the stiffness, the plate bends more. Okay. The same thing also happens to script A11. Its value is A11 minus B11 square by D11. So, here also the value of U also tends to become larger because of presence of B matrix. So, this is what I wanted to discuss today. Tomorrow we will start implementing the boundary conditions and see what the actual solutions look like. Thank you.